Hello everyone. Here we have a very beautiful question of the refraction. There is an equilateral prism. A ray enters the prism from the air. So this angle we consider as 60 degree. This is also 60 degree and this is also 60 degree since it is mentioned as the equilateral prism. This prism has refractive index 1.5 and thereafter there is a slab as shown. These two faces of the slab are parallel. It's mentioned in the question. Now this light ray is going parallel to the base of the prism. Here is the condition given. We have to find this theta. Okay. So let us start the calculation. Suppose we look at this surface and we draw a normal. This is a normal. For this normal, if we check, the angle of incidence would be 30 degree because here will be 60 degree. This angle and this angle must be same. This angle and this should be same. So this should be 60 degree, means the angle of incidence is 30 degree. The angle of emergence we are considering as E. Okay. First of all, at this surface we are using the Snell's law. So we should write 1.5 sine 30 degree n1 sine I is equal to the refractive index of the air here is taken as 1 sine E. Okay. Refractive index of air was 1 and then sine n1 sine I is equal to n2 sine I. This is equation number 1. Now we look carefully. If this is E, this should also be E. Can you see the alternate angles? This line is a normal. This line is also a normal. These two lines are normals. Okay. And then a straight line cuts like this. Let me draw it with other color. This is a straight line cutting. So this angle and this angle should be same. Okay. Now marking the other angles. This angle should also be E. If this angle is E, this should be E. You remember this thing. If this angle is E, this should also be E. So here we have marked E. But angle we always consider in optics with respect to the normal. So the angle here is 90 degree minus E. Do you agree? Now if you extend this normal again, this normal here like this, it is making an angle 90 degree here. This is 90 degree minus E. So this should be E because the summation of the interior angles of a triangle should come out to be 180 degree. See it, 90 degree plus 90 degree minus E plus E. So plus E minus E getting cancelled out, 90 degree plus 90 degree becomes 180 degree. If this is E, then we can tell the angle here with this normal should be 90 degree minus E. We consider the angle with the normal only. Okay. In ray optics, we consider the angle with the normal. So angle with the normal is 90 degree minus E. Now we'll be using the Snell's law at this surface. If we use Snell's law at this surface, we should write 1 sine E n1 sine I is equal to n2 sine 90 minus E, which is 2 sine 90 degree minus E. Do you agree with this? N1 sine I is equal to N2 sine R. We always consider the angle with the normal. Keep that in mind. Okay. Now, here again we use the Snell's law. So here we should write 2, I am writing it with a different color, 2 sine 90 degree minus E is equal to 2 sine 90 degree minus E is equal to 1 sine theta because outside there is air only. Do you get this expression? 2 sine 90 degree minus E is equal to 1 sine theta. Now we have three equations and the question is asking us the angle of emergence theta. But we have one interesting thing observable. 1 sine E can be replaced by 2 sine 90 minus e. At the place of the 2 sine 90 minus e, we can again put 1 sine theta. So from equation 1, 2 and 3, if we check carefully, shall I write that 1.5 sine 30 degree should be equal to 1 sine theta? This 1 sine e can be replaced by this parameter. This entire parameter eventually is equal to 1 sine theta. So let us simplify. 1.5, I am writing it as 3 by 2. Sine 30 degree is 1 by 2 is equal to sine theta. Our target was to get the theta. I think we have the answer now. The theta comes out to be sine inverse 3 by 4. This is the final answer and it matches with the first option. Few smart students can even figure out this answer with less calculation. How? You see, these two faces are parallel. Due to these two parallel faces, what will be the deviation in the incident ray? The deviation in the incident ray will be 0. I hope you remember this. In your physics class, you might have read this. If you send a ray of light here, the emergent ray is actually parallel to the incident ray. So the deviation in this ray is actually 0. Now, instead of having figure like this, we have two parallel surfaces like this. So angle of incidence here was E. Then the angle of emergence theta will also be equal to E only. So actually here you can figure out that this slab is giving no deviation to the ray. So whatever angle comes out here as E, the same angle would be that theta also. So simply you can find E here and this E will be actually equal to theta. So just in the first step, we will get the answer. I hope you understood the solution. If you have any doubt, please write your doubts in the comment box. We'll discuss them and we'll resolve them. If you have watched the video up to here, please like this video, subscribe to this channel and please share it with your friends. Thank you and stay awesome.